Hello, everyone, and welcome back to the 5th European Space Generation Workshop, Space for Earth and Humanity. We hope that you really enjoyed the last days of the event, Friday and Saturday. And we are here today with a new keynote by Diego. Welcome, Diego, and thank you very much for being here with us today.
Welcome, Laura, and thank you for having me.
So Diego is a telecommunications engineer and co-founder and chief operating officer of Alén Space with more than 10 years experience in small satellites. And today he's going to talk to us about the history and future of the nanosatellite industry. So we're very, very excited to hear all about this, Diego. So you can share the screen if you want to, and the floor is yours.
Okay, thank you very much. So let me share my screen. Just 1 second. There we go. I hope you are seeing now the presentation.
Yep, you can put it in full screen if you want. Perfect. Thank you very much, Diego.
Okay, so you can see it properly, right? Okay, so well, for today I want to introduce you about our vision about the past and the future of the nanosatellite industry. I am Diego Notar, and I am COO of Alén Space. And well, in Alén Space, we have been working with nanosatellites, Cubesats, since 2008. And well, we hope we think that we have quite experience in this sector. Okay, so we can share with you our experience, our vision about what happened in the past 15 years, and we expect to happen in the next years in this nanosatellite industry. Okay, well, Alén Space, in Alén Space we develop satellites, nanosatellites, and hardware and software related with this for companies that they may have a business model based on space applications, but maybe they don't have the experience or they don't have the technology to build the final solution. So we are like the technical partners, okay, to develop the technical solution in space. So first of all, let's talk about what's a nanosatellite. I'm sure that all of you know about nanosatellites and Cubesats because, well, they become very popular in the past years, okay? But maybe 20 years ago, they were not so popular, and maybe not so many people know about them. So when we talk about nanosatellites, theoretically, we talk about satellites between 1 and 10 kilos, okay, of mass. But we used to talk about, actually, we used to talk about Cubesats, okay? This is like the most popular standard about nanosatellites. There are other nanosatellites that they are not Cubesats, but most of the time when we talk about nanosatellites, we talk about Cubesats. So what is a Cubesat? Okay, a Cubesat was a standard invented by Jordi Puig and Bob Twiggs. Well, more than invented, we can say defined by Jordi Puig from Cal Poly University and Bob Twiggs from Stanford. It was defined in 1999 in California, but actually the first Cubesat was launched in 2003. Okay, starting what we call the Cubesat era in the space industry. And well, what was the Cubesat standard? Actually, the Cubesat standard was very simple. They only define, or they only standardize the interface between the launcher and the Cubesat. They only define like this mechanical interface, these rails in the satellites that they will be in contact with the deployer. Like it is like a box where the satellites are introduced in order to be launched. Okay, and apart from this interface, they also define a set of requirements, very simple. They define this requirement only to be sure that the CubeSats that they were launched with a very big satellite, okay, don't put in risk the primary mission. Okay, so the different launches that they allow to deploy this kind of CubeSat, they were not afraid about these small satellites that on that time they were like university satellites. Okay, so they don't feel like they could damage the primary mission. So they define these kind of requirements like, okay, you cannot be power on during the launch, or you have to wait 30 minutes before deploying anything like an antenna or a solar panel or whatever. You have to be sure that you are separated from the other satellites. Okay, and everything was focused in order to these launchers to be sure that these CubeSats they will not damage the primary mission. Okay, and this started everything. Okay, this very simple specification, very simple standard started everything. Okay, if you compare these small satellites that they are only centimeters of size with this very big satellite, there are a lot of difference. Okay, of course, when we talk about large satellites or conventional satellites, we talk about hundreds of kilos, tons, even tons of mass with hundreds and thousands of millions of euros of cost, and maybe 1 decade of delivery time. Okay, but when we talk about nanosatellites, we are talking about satellites that they cost less than 1 million euros, much less in most of the cases. And what for me is more important, they can develop it in less than 1 year. So this allows the developers to design a satellite, launch, test it in space, and then change anything if it's not working properly and launch it again. Okay, in maybe a couple of years, you can have your satellite tested in orbit, and you can change wherever you need and launch it and launch again. Okay, so this is what for me started all this revolution of the nanosatellites. And well, of course, you cannot pretend to have the same performance with a very big satellite than with a nanosatellite. They provide services to solve different needs, like the big satellites, okay? But in most of the cases with less performance. For example, if you want to take a picture of a car or a person from space, you will need to use a very big satellite. It's impossible to do it with small sats, okay, or with nanosats. But maybe if you want to track airplanes, or you want to track ships, or you want to provide an Internet of Things communication service, for this kind of applications, they can provide comparable performance or even the same performance than one satellite. And it is for this kind of applications that the nanosatellites are used. Okay, so as I said, well, everything started in California, in the USA at the beginning of the century. But what happened in Europe? Okay, so the first coordinated effort in Europe was made by ESA. In 2008, ESA was working on its new launcher, the Biga, okay, the small launcher. Well, they thought that maybe for the first flight, they can offer different universities across Europe to launch the new satellites, the CubeSats, in this launch. Okay, it was the first flight, and of course it was a risk that everything goes wrong and the launcher failed. But they they open this call for proposals for the different universities, so they can like apply for a slot in this first flight of Biga. And well, they selected 7 universities. The launch was successfully, and in 2012, these 7 Cubesat were launched. Most of them were operated properly. So it was like a success from ISA. And after this, other efforts were made. For example, with QB50, that it was promoted by European Commission. It was another example of the Cubesat utilization in Europe. So until that moment, the Cubesat were used by universities, for example, well, to train students. Most of the satellites were launched by universities, and they were designed and manufactured by students. But at some point, well, one small company called Planet, they thought that, okay, well, these satellites, they are being launched, they work in space, most of them, they are work properly and they can be operated. And well, maybe we can use these satellites not only to train students, okay, or to make science, but maybe we can provide a commercial service with this kind of satellites. So they start a new startup called Planet Labs, okay, later called Planet. The service was related with taking pictures from space, okay. They thought that, okay, maybe we cannot take a picture with the resolution of a big satellite, but maybe if we launch a lot of satellites, hundreds of satellites, we can take one picture or pictures of every place in the world every day. So it was like the business model. We cannot provide 1 meter or some meter resolution, but we can provide pictures of every day. Okay, so they launched the 2 first satellites in 2013. They were a success, and 1 year later we launched the first fleet, the Flock 1 constellation, composed of 28 satellites. They are like the ones of the picture here, and it was like impressive for that year. You have to think about that for that time. Maybe 1 year, only 50 satellites were launched every year. So to one company to launch 28 satellites in 1 year, it is like amazing. Okay, so this changed everything, and then they got more money, and they 3 years later they set a new record with 88 satellites launched at the same time, and at this moment they count with more than 400 satellites launched. Okay, and for this it was like the demonstration that a commercial company can start a business with this kind of satellite, and this changed everything, because from this point, different companies start working on launching their own constellations, with launching their own business models, and venture capital, and they start thinking about investing in this kind of companies. So this is what this company maybe start what we call the commercial era of the nanosatellite sector. And the other company that they follow these steps a couple of years later was Spy Global. Okay, they launched its first satellite in 2014, and up until today they have launched more than 100 satellites. So at this moment, well, these two companies, they are the only ones that they have successfully deployed a constellation. Okay, you maybe have heard about many different companies trying to launch constellations, and they are working on that, and I hope that they have success. But these two ones, they are the only ones that they have achieved that. Okay, until today. Let's see in the next years what happens with all the new startups that they are working on their own constellations. And well, constellations are important because maybe with only one satellite, you can perform science, you can perform an experiment, but if you want to provide a service all around the world, you need to count not only with a satellite, but a lot of them around the different orbits, okay? And well, covering all the Earth. Okay, this is important not only to cover the Earth by itself, but also because if you have only one satellite and it fails, and all your service rely on that satellite, all your company goes down. Okay, with the satellite. If you have 100 satellites and maybe the 10% or the 20% of the satellites fail, you still can provide. You still can provide in the service, okay, maybe with low performance, but you can still provide in the service. And with a constellation, you can continuously update the technology, because maybe you launch 100 satellites, and maybe the next year you launch 20 new, and then another 20, and every satellite that is launched, it comes with new improvements. For example, for the planet constellation, maybe the first satellites, they have like a bad resolution camera, low data rate transceiver, but maybe for the next year they improve the camera, the next one they improve the transceiver to download more data, etc. Okay, so this is very important, and this is why with satellites we always talk about constellations, because one unique nanosatellite, well, maybe it's not useful for many things, but a constellation of them, they are. And well, I will go fast in this slides, because well, with these satellites we can provide many different services, like for example communications, for IoT communication, spectrum monitoring. They are very useful, for example, for interference detection, for asset tracking, like plane tracking, vessel tracking. For example, the pictures of the right, they are real data of our satellites, our IDSB payload in our satellites. For example, the left one is flight radar, this web page, but the left one is real data from our satellites. Other application is Earth observation. Maybe we cannot take very precise pictures or very precise monitoring with these satellites. But for example, this is a case of a formation flight with each satellite with integrating a different payload, and all of them taking different measurements, like a big satellite. Okay, and of course, for science, these two nanosatellites were launched by NASA. They were launched to Mars, and well, they demonstrated that they can be very useful in deep space exploration, because they were used for relaying data from, I think that was inside rover, to relay data from the surface of Mars to the Earth. Okay, and it was a success. So well, we think that this market, it has a huge potential. Okay, you have to think that in 2012, when we launched our first satellite, only 50 nanosatellites were launched worldwide. Okay, during all the year, and during the last years, we are seeing that we are launching more than 3 or 400 nanosatellites worldwide. And we expect to launch more than 2,000 nanosatellites in the next 5 years. So this market is growing. It has a huge potential, and we think that it will be the center of the space revolution of the next years. So what we can expect from the future? As I said, well, the space industry is moving very fast. Okay, we are seeing about Mars exploration plans from SpaceX. We are seeing plans for new constellations, also from SpaceX, but also for orbital building, etc. And we think that the nanosatellites will be at the center of these new trends. Okay, they are growing very fast, and we expect to continue growing very fast. So in the next year, we will see many advantages, many advances in the technology development. Okay, for example, electrical propulsion. We are seeing now that this is a new trend. We will see new type of batteries to increase the life of these satellites, and for example, inter-satellite link subsystems for the new constellations, etc. We will see that every time the spaceships will be more affordable with the series manufacturing, and we expect to have new type of launchers. Okay, more affordable, with more frequent and dedicated launch opportunities, and we think that this will enable newer business models, different than the ones we are seeing up to now. Okay, for example, in orbit servicing, for refueling geosats or deep space operations, as I said, like space exploration. For example, we will see that, for example, asteroid mining, maybe not in the next 20 years, but maybe in 2050 we start seeing asteroid mining, and we think that the nanosatellites will be very important. And what is more important for us is all related with data. Okay, we think that we have to start talking more about data and less about satellites. Okay, and in the center of any business model of the future. And just for finishing, very quick, because we have not a lot of time, and we want to reserve some time for questions. Just a brief history about Alén Space. As I said, we started in 2008. Okay, we are one of the universities selected in the VIGA Maiden Flight from ESA. We started in the university. We are a spin-off company of the university, and for us it was our first experience. Okay, so we started on that moment as a team. Okay, and we launched with Cubesat. Our first satellite was the first Spanish satellite, and until today we have launched. We have developed or participated in the half of the Spanish satellite launch until today, and unfortunately, all of them they were successfully operated. We have a lot of experience. We have more than 13 years, first as the university, and then as Alén Space, like a spin-off company of the University of Vigo. We have worked in many different missions from the beginning to the end. And what is more important, we have a very powerful team of engineers, and we mix people with very strong technology background with people with business experience, and this is for us the core of Alén Space. Okay, our people, that is the more important part of Alén Space, much more than the technology, and this is the reason that we can develop any mission or any challenge that our clients offer us. Okay, and well, we develop and we have ready to launch technical solutions, for example, predefined platforms and payloads for nanosatellites, and we perform from the beginning to the end of our satellites. So our clients only have to focus on getting the data and, well, make business data or science with this data. And well, I think that for my side is more or less what I want to share with you, and maybe we can have some minutes for questions. You are mute, Laura.
Thank you very much, Diego, for that great presentation. Yeah, we can go now straight to the questions. Thank you very much. It was a great overview of the history and also the future, the exciting future of the small satellites that we have ahead. And we have lots of comments and questions from the audience. And one of them is about the key differences between small sats and actual CubeSats in terms of potential and operational constraints. So yeah, between small sats less than 150 kilos and actual CubeSats. And the question is also, does each of them have a niche, or is one superior to the other?
Well, to say if one is superior to the other, we have to define a criteria, okay? But, okay, with small sats, typical small sats of 115 kilos, well, the more important difference maybe is the space dimensions you have. For example, if you want to board a camera, well, an actual CubeSat, you have the size you have. Okay, if 3 units, you have 50 centimeters of length. For a 6 unit, more or less the same. Well, you have this constraint. Okay, it's a strong constraint because the interfaces are standard, and you cannot like think about another shape. And if you are thinking about small sats, 150 kilos, well, you have much more space for this. You have more mass, for example, for shielding, in order to protect your electronics. What is more important, I think, you have more power. You can put more solar panels, and you will have more power to operate your satellite. But at the end, is a matter of, well, you have more power, more space, more mass. On the contrary, you have to pay more for the launch because you have more mass. Okay, but at the end, I think that the technology will be very similar. Okay, most of the subsystems that you can use in CubeSats nowadays, okay, because you have very advanced technology on board of CubeSats, you can use it on the small sat of 100 kilos, for example. So more and more we are seeing now that the subsystems of the CubeSat can be moved to bigger satellites, for example, 100, 150. But of course, with these bigger satellites, you have more space, more mass, and more power. Okay, but I cannot say that one is better or another. If you can do it with a small sat of 10 kilos, why to go to a satellite of 100? Okay, but for applications like, for example, Earth observation, it's a significant difference. And for that kind of applications, it's a big difference. Laura, I don't know if you are there.
Yep. Sorry, I was asking, yeah, the next question that we have here is, small sats have been primarily used in LEO, but do you see these moving into deep space applications soon?
Yes, I think so. We are seeing now, like not only deep space, but also geo orbits. And I think like this is like, as I said in the presentation, like one of the new business models. Okay, we will see now with these efforts about moon exploration or Mars exploration, we will see that the small sats will be one of the key parts of these explorations. Okay, not like the primary mission, but like this, like support. Okay, for these primary missions, like the Marco satellites that they were supporting it was more an experiment, but in the future will be like that. Okay, like constellation of small sats providing communication data relay for surface missions, okay, in Mars or in the Moon. So yeah, I think so. We have seen some examples of small sats, for example, for asteroids, like some missions from ESA or from NASA, and we think that in the future this will be for sure one of the development lines for Cubesats and nanosats.
Yeah, working together, as you mentioned before, because all the applications that you were mentioning for the future, like asteroid mining and all of that, is clear that we need that both combined, right? Like bigger satellites, but with the CubeSats
Yeah,
and space
yeah.
together.
We have the constraint of the radiation. Okay, that is important, but we are seeing that every day the technology is better, and I think this is something that we will solve very soon. I think.
Perfect. Okay, we have the last question that talks about ground stations. They're asking how typical ground station for nanosatellites look like, and are mission control and data acquisition on the same ground station's location, and how small satellites are tasked or receive the commands and send the telemetry. So, do they all have this ability, the two-way communication with the ground station?
Yes. Well, how it looks like? Okay. Well, usually we are used to see ground stations maybe simpler than the big antennas for big satellites. But at the end, you have the same architecture that any other ground station. You will have depending on the on the frequencies used, UHF, S-band, X-band, L-band also, depending on for uplink, downlink. We will see, and we are seeing companies that they are providing services with ground stations, so you don't have to have your own ground station. You can rely on ground station networks, and I think it's very useful. But of course, if you want to have the control of your own satellite, the solution is to have your own ground station. And I think it's quite simple nowadays. For 50,000 euros, you can have like a complete ground station with all the antennas, all the radios, amplifiers, etc., and all the mission control infrastructure. Okay. For example, in Alén Space, we commercialize this kind of ground stations, antennas, the radios based on software-defined radios, etc. And regarding the telecommands and telemetry, well, they are operated in the same way that any other satellite. Okay, I think that it doesn't depend on if it's a big satellite or a small one. I think that the telecom and telemetry architecture is more or less the same, or at least can be the same. Okay, then it will depend on the mission and how every team design its mission. But for example, for our satellites, we work with the packet utilization standard from ESA, that they are the same standard the big satellite use for operating the satellites. Mm-hmm. Of course, there is a difference between GEO satellites when you always have a link with satellite, because it's always there. With LEO satellites, that you have different passes depending on the day, and you have to switch to different ground stations. But it doesn't depend on the size. Okay, it depends if it's a LEO or a GEO satellite.
Great. Okay, thank you very much, Diego. We ran out of time, but thank you so much for your answers and for the great presentation. We're sure that all the delegates are now looking forward to see a little bit more about Alén Space, and any questions, we will defer them to you. Thank you so much.
Thank you very much for everybody, and please visit our webpage, and you can know more about Alén Space and about our history and the history of the nanosatellites.
Great. Yeah. Also, because Diego, you have very great training programs and lots of material there that I've seen before. So yeah, I encourage everyone that is learning about nanosatellites to visit, because it's very, very good material there. Very interesting. Thanks a lot.
Thank you, and have a good workshop.
Thanks a lot. Bye.
Bye-bye.